Hi, in this video we're going to talk about parallel lines and transversals. So this little symbol right here is telling us that M is parallel to N. It's this little like arrow that means parallel. So whenever you see these little marks, like arrows in the middle of the line, that's telling you, hey, these two lines are parallel. So in here, we've got our vertical angles. We've talked about that in another video. 2 and 4 are vertical, 3 and 1 are vertical, 6 and 8, 7 and 5. Those are all our vertical angles. Linear pairs are the ones that are right next to each other. So doop, 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 doop. And then we've got a new vocab word, this idea of corresponding angles. So if we look at 2 and 6, 2 and 6 are both in kind of this upper left-hand corner of this shape. So these are in corresponding spots. We could say the same with 5 and 1. These two are in the upper right. Then in our lower left, we've got 3 and 7. They're in the same corresponding spot. And 4 and 8. 4 and 8 are in the same corresponding part. So same relative position in this kind of diagram that we've got. Now, what's really cool that we're going to learn is that when that happens, corresponding angles are congruent. So 2 and 6 have to have the same value. Same with 1 and 5, 3 and 7, 4 and 8. So those are always going to be nice congruent angles. Some other angles that do some more weird things. We're going to break them down first because corresponding, pretty straightforward. These ones get a little weird. There's alternate angles, angles that are on alternating sides of the transversal. So they're swapping sides of this transversal up top. There's also same side angles, so they're on the same side of the transversal. So 2, 3, 7, and 6 are all on the same side. Exterior angles are on the outsides of the transversal, and interior angles are on the inside of the parallel lines. I said transversal before I meant parallel. Let's look at some. Let's look at some. Okay. So here we've got 1 and 2. So we're looking at 1 and 2. Now these are my two parallel lines. Let's just put the little parallel symbol on them. So 1 and 2 are exterior angles because they're not kind of like being wrapped up by these parallel sides. So I know they are exterior. 3 and 4, however, are inside of these two lines. So 3 and 4 are going to be interior angles for this thing. 5 and 6 are like one's kind of like inside the thing and 5 is outside the thing. But wait, look, they're both in kind of the same spot. Like, see how 6 is kind of at the top part of this X right here, and 5 is in the same top part of the X that's over here. So these two are corresponding angles. Now with exterior and interior, we're always going to pair them with either same side or alternate. So let's look at 1 and 2 again. So are they on the same side of this transversal or on the opposite side? Well, they're both on this side of our transversal. 3, 5, and 6 are on the opposite side. So these are same side exterior angles. Meanwhile, 3 and 4, in order to get to from 3 to 4 or 4 to 3, see how my pen kind of travels to the other side of the transversal, unlike 1 and 2 where I stayed on the same side. So these interior angles, these two ended up being alternate interior angles. Now you might say, big whoop. Well, what do we care about these things? They're not cool and congruent like corresponding angles, are they? Oh, yeah, they are. There's ways of writing this out long form, but if two parallel lines are cut by a transversal, then the following are true. Theorem 3-7 says that alternate interior angles are congruent. Theorem 3-8 says alternate exterior angles are congruent. Theorem 3-9 says that same side interior angles are supplementary. Reminder that supplementary means 180 degrees. And 3-10 says same side exterior angles are supplementary. So you can kind of see the same side ones are supplementary and alternate angles are congruent. Important that you're also pairing it with this, that they're exterior or interior angles. So let's play around with this. If we know the measure of angle B is 42 degrees, so then we know this is 42 right here. And I did a quick solve to figure out what supplementary to that was. It's 138 degrees because I'm going to need that for this supplementary stuff right here. So if this is 42 degrees, if we get the alternate exterior angle, so alternate exterior, I need to go to the alternate side and be on the exterior with that B, this H by theorem 3-8 needs to be congruent to 42. So the measure of angle H needs to equal 42 degrees by theorem 3-8. If we look at the vertical angle with B, vertical angles is telling us that C, the measure of angle C, is going to be 42 degrees as well because it's a vertical angle. Going back to our table up here, our alternate interior angles, so C and E are alternate interior angles. They're inside of our parallel lines and on alternate sides. So we can say the measure of angle E is also 42 degrees. So that's by theorem 3-7. If we want same side exterior, so B and G, they are both on the exterior and they're on the same side of this transversal, these two need to be supplementary. So that's going to be my 138 degrees, so that's theorem 3-10. If I get my same side interior angles, so that's maybe C and F, then I'm able to say that F is got to be supplementary with this 42, so that's another 138. Finally, if we think about corresponding angles, I've marked the angles we found so far. We can say, oh, G and D have got to be the same, and F and A have got to be the same since they're the same corresponding parts. So we can say that the measure of angle A has got to be the same as F, which is 138 degrees, and the measure of angle D has got to be the same as G, which is also 138 degrees. We can do that using postulate 3-1. There's other ways of talking about like where those angle measures can come from, but that's what I chose to make sure that I could use the most of that table up top. In this example, I need to name the two lines in the transversal that form the pair of angles. So using proper notation. So that transversal is got to be something that is touching both of my angles. So I really want this to be my transversal. And then the two lines that are going to uh, that are going to be parallel with each other are the ones that are kind of like working off of that transversal. So these are going to be my two pair of parallel lines. So I've got my transversal that touches the two angles that I'm talking about. And then the parallel lines have got to be the ones that connect off of that transversal to make my angles. So my transversal is going to be this line right here, AH. And then my parallel lines are going to be AT and MH. Now it's kind of tricky to see what's going on over here because of all the other lines that are going on. So what I would recommend you do is just over the side here, so we can decide what kind of angles they are. I would just make a quick copy of that thing. We've got our horizontal line for our transversal. We've got our two parallel lines. Our first angle is right here, and our other angle is right there to kind of get rid of some of the mess. So if I'm looking at what kind of an angle this is, I can tell that these two angles are on alternate sides of my transversal. So I know it's either going to be alternate interior or alternate exterior. They're also both inside of my parallel lines, which means interior. So HAT and MHA are alternate interior angles. All right, now this alternate interior angles thing is something that's going to stick with us for a long time. So this is a shape that we're going to be dealing with later. But it's got parallel sides and these two angles, and we want to know which postulate or theorem is backing us up. Now, right here in this diagram, it's tough to tell what is exactly going on. But if I rewrite it, we've got that line on the top, we've got that line on the bottom that are parallel with each other. And then there's some line going on over here that's got x and x plus 20. Once we do that, we can say, hey, those are both on the same side of our transversal, this line right here, the same side, and they're inside of our parallel lines. So these two are same side interior angles. If I go back to the previous page of my notes, same side interior angles is theorem 3-9, so those two must be supplementary. Since they are supplementary, I can write a little equation. I can say x plus that x plus 20. If I take my two angles and add them together, they better equal, for supplementary, 180 degrees. That's what I got since they were supplementary. Well, that's a little equation that I could solve pretty quick. X plus x is going to be 2x plus 20 equals 180 degrees. Subtract 20 from both sides. So I can start getting that x by itself. We get 160 equals 2x. Divide both sides by 2. X equals 80. Okay, so I determined the value of x, and I want to know the measure of each unknown angle. Now, the first one's easy. That one right there, that one's got to be 80. So the measure of angle, let's call it properly. It's this angle W here, or we could say OWD. OWD equals 80 degrees. If we look at this angle down here, angle WOR, that's got to be 80 plus 20. Oh, 80 plus 20, that's going to be 100 degrees, which is good because then that 80 plus 100 is supplementary 180 degrees. To wrap up for today, the idea of this alternate exterior, same side interior, etc., this is the major thing that we're going to need. It's something that is going to come up over and over again in our work with geometry, and it's something that sticks with people for a long time. If you ask a lot of people about, hey, do you know about same side interior angles? They're like, hey, yeah, I remember something about that. But it's your turn to learn about it. So that's it for this video. Thanks for watching. Bye bye.